folks, welcome to the very last video of our electrostatics unit. In this video we're going to talk about proportionality, and by the end of this video you will be able to solve electrostatic problems using ratios. So let's get started with this question. Can you solve an electricity problem without numbers? Go ahead, pause this video for a moment and think about it. Maybe write down your answer. Maybe think about some problems you might need numbers to solve and some problems you'll be able to solve without them. So, spoiler alert, the answer is yes, you can solve problems without numbers. And we're going to go ahead and talk about that with an example. So, two charges are separated by a distance d and feel an electric force F between them. The distance between the charges is doubled. Find the new force, F new, in terms of our initial force F. So I know that my electrostatic force in general, so I'm going to just call it Fe, is equal to KQ1 Q2 over R squared, which here, so that's going to be my equation. So for my very first charge, in my first situation, my equation is going to be F is equal to K Q1 Q2 over the distance between our two charges squared. And that is going to be for our first situation, when our charges are separated by a distance d. So what happens when the distance is doubled? Well, d new is going to equal 2 times our initial distance. So I can again write that equation, and I'll say F new is equal to K Q1 Q2 over 2d, and that whole thing is going to get squared. So I can also say F new is equal to K Q1 Q2 over 4d squared, because I have to distribute that squared to both the 2 and to my variable of distance. So how do I get my new force in terms of my old force? Here's what I'm going to do. I'm going to say force, my initial force over my new force is equal to K Q1 Q2 over d squared divided by K Q1 Q2 over 4d squared. And what I'm doing is I'm just expanding that ratio out. And when I do that, I am using the relationship between F new, D, and D new to figure out the relationship between F and F new. So when I simplify that fraction out, what I get is I get K Q1 Q2 times 4d squared over K Q1 Q2 times d squared is equal to F over F new. And at this point, I'm going to go ahead and shrink down what I've already done because I'm starting to run out of space a bit. I'm going to move that up to the corner and continue on. So I can cancel out my K's, both of my Q's, and what I get is that F over F new. Oh, and sorry, I forgot. I can also cancel out my d squareds because I have those on both sides. So I have F over F new is equal to 4. Or F new is equal to F divided by 4. So I have successfully solved this problem without having to use any real numbers. But there is actually an easier way to solve some of these problems. I'm going to do that in my second example. So in example 1.9.2, at point P, which is 2 meters away from a point charge, the electric potential is V. Point Q is 4 meters away from that same point charge. What is the electric potential at Q in terms of V? So what I'm going to do is I'm going to start with my equation for potential due to a point charge. And that is V is equal to KQ over R. So what I can also say is that V is proportional to 1 over R, because we know that our K, our charge, and K is our constant, and Q, our charge, are both going to stay constant. So we don't really need to think about those two variables at all. So let's go ahead and figure out the electric potential at Q in terms of V. So we know that R at point P is equal to 2 meters. and r at point Q is equal to 4 meters, or in other words, r at Q is equal to 2 times r at P. So I'm going to do that same thing. I'm going to say, I'm going to say that V at P is proportional to 1 over r at P, and V at Q is proportional to 1 over r at Q, which I can rewrite as V at Q is proportional to 1 over 2 times r at P from my earlier work. So what I'm going to do is I'm going to go ahead and take that ratio again. So VP over VQ is going to be equal to, and the reason I could put that equal to sign in there is because we are dealing with ratios, so we're not going to worry about, so we can replace that proportionality sign here with an equal sign. So VP over VQ is equal to 1 over RP over 1 over 2 RP, or it's equal to 2 RP over RP, and again, as before, our RPs will cancel, and I can also replace VP with just my plain V. So what I'll get then is that V is equal to 2VQ, or VQ is equal to V over 2. And there you have it, folks. There is another example of a way to solve, a slightly simpler example of a way to solve our problems without using any numbers. So takeaways. First of all, sometimes it's easier to solve problems using proportions rather than numbers. And secondly, to solve problems using proportions, you'll need to solve for one variable in terms of another, and then you will, of course, divide the two variables that you're trying to find and figure out the ratio between them. So there you have it, folks. You can now solve problems even if no numbers are given. So go ahead and give it a shot. Happy solving.